Good afternoon, everyone. Welcome to the Energy and Sustainability Club's very first podcast of the season. Today we have with us a very special guest, Mr. Vardhan from Inverted Energy, where he works as team lead of battery packs energy storage.
Good afternoon, Harsh. We welcome you to the podcast today. I'm Tejas from the Department of Energy Science and Engineering, and I'm a convener of the Energy and Sustainability Club at IIT Bombay. We are immensely grateful to have you here.
So I am Ojas. I'm also a convener, and again, like they just said, we are really excited to have this conversation with you today.
So, we are here to discuss various initiatives in the energy storage field and to get better insights into this field. So, shall we get started?
Sure, we can start.
Yeah, starting off, could you walk us through your journey from your academic background to becoming the team lead of battery packs at Inverted Energy?
Sure. Let's start. And I'm Harshvardhan, and I did my BTech in engineering physics from IIT Delhi. And since the start of my career, I was more into hardware. And during my school time as well, I used to snuck off to garages and watch mechanics doing work on cars, on engines. I was prohibited from my home and my families to go and watch like the garage or work with mechanics, but still I used to snuck off and watch these guys working on the engines of cars and opening bikes and how they repair punctures, how they repairs engines and all. And that spiked my interest into the hardware and automotive designs. I used to go to the people who are building bridges and building towers. So initially at time of when I was in my fifth class, so that time telecom was like expanding networks in villages, and there were towers building in all over the villages around me. I used to go watch the workers and how they install the trusses and designs and all. So that spiked my interest. And when I joined my college, so when I was in my 12th, so I was initially interested into physics, and I was thinking I'd build some career in physics and do some research on solid state physics. I was more into nano manufacturing, condensed matter physics. But after joining my college, so after spending a month, I realized this is not what I want to do. I don't want to go into physics, into deep research, something I can't deliver to the society in coming like 10 years or 5 years. This research will take time. It will take time about 30 years or 50 years. I don't know when the research will come into practice. So I found some guys working on race car basically. So there is this automobile club at IIT Delhi, Accelerator Formula Racing. So those guys were building some electric race cars, and I saw it. Yeah, I saw they kept some gears with them during the college orientation, and I asked them, "Can I join this club?" So they said, "You'll have to wait for 6 months, and then you will join that club." So that's where my journey of hardware began. There I started designing race cars and especially electric race cars. So from there, I got to know about batteries, and right after finishing my undergraduate, I was into building my own startup. So during that period only, I got to know about Rahul Raj and Raghav Jain. So they were founders of Inverted. So one of the pioneering startup in energy storage segment, and they introduced me the challenges they are facing in battery development and what their the industry is facing challenges like. I joined around 2022. So at that time there were too many fire incidents happening in the battery industry. So like at warehouses, at in the bikes or in cars, there were fire incidents. So they were telling me these are the challenges they face, and I thought, why not solve these real world problems first? So that's how I joined the career in energy storage began.
That's really a
That's very,
remarkable and inspiring journey.
it's always wonderful to hear from a fellow IITian. So now let's get into the technical side of things a bit. So how does software, especially if I talk about battery management systems, BMS that is, enhance the performance and safety of energy storage systems?
So if we talk about BMS, BMS is not only about software, it is equipped with an hardware. So hardware is basically a control board, and the control board has its sensors along with it and some switches along with it. So the sensors are like temperature sensors, current sensors, voltage sensors. They provide the data to the memory of BMS, that's a microcontroller, and based on the feedback, so there are some logics and algorithms which you have defined in the software, some protections logics which you define, since it's a chemical reaction. Basically energy which you get from lithium ion batteries is a chemical reaction, and if it's not performed in a controlled way, it can be harmful or can be dangerous. So we have given some parameters under which it have to be operated. So those sensors provide the values to the microcontroller, and based on that, the microcontroller decides whether the circuit to be completed or it's to be closed. So there, to control, there is a MOSFET to switch it down, or there are contactors or relays to switch it down. And apart from the protection part, it also optimizes the performance by performing balancing. So what happens is, over the time, the cells gets different cells get different performance behaviors, so they tends to misbalance. And the objective of the BMS is, during charging or discharging, it tries to balance out all the cells so that they perform similar and provide longer life cycle. Apart from that, so since it's a energy source, the user also needs to be updated about the status of the charge. So there are various algorithms in order to measure the status of charge. So there is a Coulomb counting, there is a extended Kalman filter combined with Coulomb counting. So more accurate your algorithm is, the more you get to know how much energy is stored in the battery over the its usage period, so that you can predict the range more clearly. So that's the role of BMS in the battery, like batteries or energy storage system.
Okay. So it's nice to hear about all these algorithms and everything. It really excites us. From your perspective, what are the biggest obstacles to large scale grid level battery storage adoption?
So one of the biggest challenge that come at grid level adoption is the cost. The cost of the lithium-ion battery. It sure had gone down between the, like, when I joined in 2022 and over the period of 3 years, it sure has went down. But still, the cost of implementation is quite large for lithium-ion batteries to be used as an energy storage option. And apart from this, you have to manage the inverters and battery management system in such a way so that it's capable to perform the grid fluctuations which you observe at large scale grid level. So there is high grid swings, so voltage fluctuation is way too high. You see a fluctuation of up to like 300 for 400 volts. So that's difficult to manage by the inverters or transformers. And apart from that, recycling is still not involved fully yet. So if we try to implement it at large scale, we have to also figure out the recycling part as well. So these, I think, are the challenges, and we are like working on grid solutions as well. So I think in maybe 2 years from now, you would see a large scale grid adoption. So the growth of this BESS or energy storage segment as a grid storage option is growing at a rate of about 18 to 20%. So that's a high scale growth for an
Yeah,
industry.
that's great to hear, actually.
Right, sir. So how do you see the role of energy storage in particular evolving as we are as a society trying to transition to a more sustainable energy ecosystem? So how do you see that?
So, like currently, the energy sources which we are using are getting from coal. So basically, coal occupies about 40% of the energy demands of India. And when we move to more sustainable energy like wind and solar, so you will have to cater the intermittency they do, like the intermittency they provide So you can't get solar energy all the day, you can't get wind energy all the day, so you'll have to keep something for storage, and that storage needs to be localized as well. So you can't put a storage at certain place and then expect it to be supplying energy. Since transfer of DC energy is costly, as well as higher losses of energy are there. So you'll have to localize as well energy storage at your home level. And also people are now like in flats or in their homes, so if they have some villa or something, they are adopting solar panels and providing energy back to grid. As a society, we
Yes.
can develop our own energy and provide energy back to grid to transfer to others or share with others. So that's how I see this path going.
Right, sir. So also I had recently sorry, uh, let's they just take this one.
So, are there any recent advancements in battery technology that you find especially exciting or promising that excites you or your team in
Yeah,
particular?
yeah, sure. So one of the thing which is exciting to me, like there are basically two things. So the first one is fast charging. Obviously,
Mhm.
that's going to revolutionize the logistics industry. Since the logistic cost of India is about 13 to 14, 15 rupees per kilometer, that's quite high price as compared to other countries like Australia or even US. So there are the costs like 5 to 6 rupees per kilometer. So if we are able to use fast charging at the grid level, we would be able to change the current logistic systems from internal combustion engines to energy battery energy systems. So there you would get a logistics cost reduced highly. And apart from that, fast charging will also help in adoption of more electric vehicles in cities as well as in its villages. And the second thing which I believe is more exciting is the solid state chemistry. So currently it's highly costly or not being able to the meet the cost requirements of the government or other local public. And if that solid state battery is high energy dense, there are better opportunities on fast charging it, and as well as safety point of view. So if you are able to bring down the cost of that solid state energy, solid state battery packs, then I think that would be a really exciting.
Yeah, that will be a breakthrough for us. So, now coming to the policy side of things, in your opinion, what policies of regulation do you believe are crucial for accelerating the adoption of energy storage technologies?
So
So,
coming to
how
the
can
policies, yeah.
yeah,
So the
how can
government,
governments
yeah, sure,
Mhm.
sure. Go ahead.
Okay. How can governments and industries work together to create a more favorable environment for energy storage innovation, according to you? Like, what are
So
your
I,
thoughts?
yeah. So government is already working on it, and I see more and more policies coming up in the favor of industries and startups. So they are providing more freedom to startups in developing their energy storage segment and providing more subsidies to the users who are adopting electric vehicles. As well as what I believe is they can also put some money on the research part of lithium ion energy. So currently what's happening is we are importing large scale of lithium ion batteries cells actually from other countries like China and like nearby countries. And what's happening is we are so much dependence on the those countries such that our energy dependence is becoming on this. So if you are moving to a lithium ion chemistry, we are highly dependent on them. So what can government do is push industries more on research side instead of just uh, using make in India. We can go for made in India. So for made in India means the research part is happening in the India. We don't need to be assembling here only. We also need to deploy and build our chemistries here itself with the raw materials which are available here, so that we can remove all our energy dependency from other countries.
Yeah, that's a great
Right. So
point.
that was very insightful. Thank you. So I recently came across a paper written by the New Jersey Institute of Technology where they were using AI to study different combinations of materials for battery usage, especially if I talk about, say, materials like magnesium, which are, of course, more abundantly available, and are also multivalent carriers, unlike lithium. So, what is your opinion on technologies like these new innovations like this?
Sure, sure. Though we can like exactly like magnesium, people are also exploring sodium as well. So sodium is equivalent to lithium in terms of valency. And the problem with the sodium and magnesium is they have higher mass. So the energy
Yes.
density of this chemistry would go lower, and that will cause the automotive balance to disrupt. So I think that will be challenging if we adopt it at automotive level, but we can surely adopt it at storage level. Also, the other part was the price of lithium ion chemistry. So over the years, it has went down, and sodium ion and magnesium ion were only researched to meet the price levels of lithium ion and cater the price points. The energy wise, lithium ion is always higher than the sodium or magnesium ion, but we can surely use it as an option for energy storage segment. But for automotive, I think it's highly competitive chemistry, because for automotive, it needs to have a lighter mass on the energy side or the weight side.
Right, sir. So also, like the researchers are also increasingly using AI. So, is AI also playing a role in designing and testing of battery packs in your work?
Yeah, yeah, absolutely. So we are using AIs for predictive maintenance of our battery packs. So we have seen trends and how do batteries get failed after a usage of 2 years, or what are the characteristics which they develop after usage of 6 months or so. So we plant those, or we train our AIs similarly. If you see those trends, we can already predict those failures. And also we are developing the thermal models as well, and the mechanical analysis is being done by like our AI models. So we just feed the data and they provide us like these are the failures which can happen. So in this way we are employing AI in the battery field.
That's really insightful. So, coming to our next question, what advice would you give to students and young engineers who want to enter the energy storage field? What do they
So,
need to know prior?
sure, sure. So what I believe is getting to know about theories is good. Like you are already students of energy department. I believe you are already getting to know about what all chemistries are used and how do lithium ion works and all these things. But what exactly they lack is hands-on. They lack
Mhm.
hands-on, like let's say even you have to design any kind of box itself or any kind of fastener or anything. So there is a one saying in Formula Student. So I'm a Formula Student guy. I've been a part of automotive club in IIT Delhi, and I truly believe in Formula Student. They bring industry ready engineers in the market. So there is this popular saying, students nowadays know how to calculate stress and strain in a fastener or in a bolt, but they don't know in which direction to turn to tighten it. So they really like
That's really
hands-on on the projects. And what I believe is you can get hands-on, you can build any projects with your collaboration with your teams or professors, get to know more about real world failures they face. So what exactly you design in systems never actually comes to real life. You design beautiful designs in CADs and drawings, but you are never able to replicate it. So that what exactly I would suggest to students. And theory part you can always figure out. So you guys have cracked Premier One student and so Premier Institute. So you already know what to study and what to. But what exactly is, you know the failures. If you know the failures, then you are
Mhm.
ready for the industry.
Yeah. I think I'm sure our listeners will truly appreciate this.
Right, sir. So, what are the current market trends in energy storage, in your opinion, especially considering the very, shall we say, uncertain global political landscape?
So current market trends are like, since this market is saturating right now, the two-wheeler and the three-wheeler battery energy. But the market which is growing right now is the energy storage, BESS. So it's a storage options for grids for factories. So they start with the energy capacity like 418 kilowatt hour and goes up to megawatt hour. So current Indian market is about the BESS market is 700 to 800 megawatt hour, but in 2 years it's gonna be 100 gigawatt hour market. So that market is something which is growing, and if you want to invest or learn about this, so this is something we can like focus on. And in terms of energy dependency, so I believe this dependency will be continuing on for at least 10 to 15 years more. And the research which is going on in India in developing the own chemistry, it's still evolving. The people who are building cells and batteries are not yet able to fully replicate the performance which we are getting from other countries. So that reliance would be still in the hands of other countries.
That's really nice to hear that. So, how do you address the recycling and disposal of batteries to minimize environmental impact? As you know, lithium and sodium batteries.
Yes, sir. So before recycling, there is one more use, reuse. So people are now exploring second life of the battery pack. So what happens is, in automotive, if a battery degrades to 80% by 20%, so we claim it not usable for automotive sector. But the battery is still usable, the energy is still there. So people are developing more advanced algorithms and more advanced BMS softwares to use it in an energy storage segment. So it can be used as a second life battery pack. Yeah. And another is recycling
Great
it
to hear
out
that.
to,
Yeah.
yeah. So another is recycling it out to extract the
Mhm.
metals and abundant chemicals, so that we can make it another battery pack. So there are companies like Lohan Cleantech, Batex, and Reliance is also involved in recycling these battery packs. But still, it's a evolving tech, and we can add more value to it by making cells from this recycled material.
Yeah. Okay. I hope we prioritize this in future.
Right,
Yeah.
right, sir. So, so coming slightly off topic a bit and maybe possibly into the boundaries of controversies. So recently, I'm sure, as you know, that our Mr. Hardeep Puri announced that a lot of oil has been found in Andaman and Nicobar Islands, which could, which is almost like a Guyana type find for India. So, how how should that oil be used in your opinion? Should we go all out in using it for energy security, or should we just keep it as a reserve and focus on sustainable technologies, or should we meet somewhere in the middle? What do you think, sir?
So what I think is, in my opinion, is the very first thing I want is independency from other countries. So
Absolutely.
in energy segment, basically, so there are two segments where I think independency highly required. The very first segment is defense, where I believe we need higher independence from other countries on, or reliance on the defense segments or the rockets or any equipments we use or armories. And the second is the energy segment. So if any other country has a control of us in energy, we won't be able to like survive, or to let them have control of our energy gives them control over economy as well, our growth as well. So if we can use that source to release the dependency, I think that would be a great thing. So currently, where energy dependency is about 60% on other countries, so we can reduce that dependency. That's how I think it should be used. And more on the research side is something which can be parallelly done in order to do more better on the sustainable part and the storage part.
Right. So thank you for that interesting bit of perspective. Tejas, do you
So
want to take
coming
it?
to our yeah, so coming to our next question, which emerging markets do you see as having the greatest potential for energy storage solutions, and why do you think so? Like, according to you, why?
So currently, as I told you, the this BESS market, which is growing at a high rate of about 20%. So that's the one of the emerging market. And since we are moving to more on the like sustainable part of the energy storage as well, so we need a better energy storage solutions. And I already told you this market is gonna be 100 gigawatt hour in 2 years. So that's quite a big number for the energy market. And also, I believe the energy storage is going to be more highly approachable and relative in the logistic market as well. So light commercial vehicles you would be seeing in the roads would be battery powered. The buses you would see currently, like the adoption is high in the metro cities, but still it needs to be at village level or at the higher network level. So these are the markets where I see the growth to be happen in the energy storage part. And why I predict this, because I'm connected to this market and I see companies researching on this. I am getting requirements from the companies on this type of batteries. I am myself building a 418 kilowatt hour battery pack. So that's for that can power our two factories. So where we are producing battery packs, so it's a combination of battery, PCS, a liquid cooling system, and energy management system. So I see this is where the growth is happening.
That's really exciting to hear that and the future opportunities. Oh, yes.
Right. So, how do you, in your work, try to integrate emerging technologies like IoT, blockchain in the energy storage systems?
Yeah, so IoT is the we are using highly. So in our current packs, which we make for e-rickshaws or two-wheelers or swap systems, so IoTs are highly required since this is a finance market. And where we give our customers battery pack with a financer as an main customer. And what they happen is they have to retrieve money, so they need to track that battery pack, where it's going, how the performance is happening. Apart from that, we as a battery designer, so since the battery itself is evolving right now, battery design itself is evolving, and it would take up to like 10 years or 5 years to evolve better. So we have to gather data on monthly basis from the IoTs to see how the performance is happening at the battery level. So that's how IoTs are being used in the battery packs. And also, in order to do remote level of firmware update over the air, and if you want to just control the battery packs over the remotely, so that's how we do using the IoTs.
Yeah, that's nice to hear that. So, we want to ask you a personal question. Like, looking back on your career so far, what moment of or achievement are you so proud of, most proud of your
So,
younger self?
uh, so there are two things which I'm very much proud of. The very first thing was during my college life. So during the start of my second year, we went to Formers in Germany. So that's one of the like prestigious competition in formula students, and we were the first Indian team to build an electric race car to clear the technical inspection of German. So that was one of the
Congratulations.
exciting moment I had, and the second
That's
one
really
which
inspiring. Yeah,
second one which I has was during my corporate journey. So at Inverted, when I joined in August of 2022, so I was initially working on developing better algorithms for batteries and better algorithms for BMS. And at that time, a new amendment to the AIS 156. So that's the amendment for the L category of vehicles, safety of battery packs for L category of vehicles. That came, and it came with lots of rule. So it affected all the battery manufacturers. All were um, this chaos was running in the factories and the industry. Like, who is going to build the first battery pack, which will be certified as a safe or to be usable for the customers. Every client was demanding a AS156 certified battery pack. So the amendment was more on like, if we any cell goes into thermal runaway, there should be a protection for thermal propagation. The battery should be IP67. There is more number of temperature sensors. The design should be more safe for users to consume the battery pack. So at that time, founders came to me, Rahul and Raghav, and said, "Ki we need our battery packs to be certified, and that too within 2 months." So we worked day and night, experimenting, discussing with the battery management system developers. We need better softwares, and we need better hardware to control the switching. We need so IP67, getting the battery pack IP67 was one of the challenging design we had to do. We were searching through rubbers, gaskets, the designs of the battery pack. So we have to design our battery pack in sheet metal. And if you ask any designer in sheet metal how to build a IP67 pack, so he would say it's near to impossible. So that we did. And when we got the battery pack certified on the March 1st, so I was sitting quietly just observing the battery packs getting tested and the approval sign getting stamped on the battery. So that was another again moment I would like to cherish.
that's your
Right, sir.
hard work. Yeah.
Absolutely, sir. In your opinion, today it is often we find that the consumers are not aware of what benefits sustainability and smart energy storage solutions can bring to them. They often see climate change as just some faraway thing that is not affecting them. So, how can you, in your opinion, can consumers better understand the importance and benefits of energy storage solutions in their daily lives?
So what I believe is it's difficult to explain everyone what exactly the problem is if they can't see with their eyes. So before joining this company, I was also concerned about global warming. It's growing highly, and current global warming is at 3 degrees Celsius. So that was quite high, and the climate is changing. And I was looking to make some carbon absorbers. So I was into building carbon absorbers for the factories, so that we can absorb carbon, sequestrate it, or like make blocks, so we can reduce the global warming. And I visited many professors in my college to their homes to ask their housewives, will they be using such kind of objects in their home as well if I build a smaller one. So don't think they were aware of the problem. They know by theory, they know this problem is happening, but they, even the educated ones, were not they were very reluctant to use such kind of products. And what I think is enforcing this kind of knowledge using policies is one of the way which government can induce in our societies to improve this thing. Or uh, it's difficult. Like, Indian mindset is like, until unless you get the problem at your hand, you don't act. Okay, so
Absolutely.
you get it on head, the blade is on your neck, then only you act. So this can be done if you want to do preventive observations or preventive measures. We can only do it by enforcing policies or
Yeah, we truly hope people will start taking actions and
yeah,
policies.
I do too.
So, uh, so what's the one key message you want our listeners to take away from today's conversation? What do you think they should take away?
So my
They
listeners
should
are
always remember.
college students, right?
Yeah,
It's
Yes.
almost
mostly.
So I would say get out of your classes, go into labs, go into workshops, and build something. Just build something. Don't like this is the only chance you get at doing failures, and nobody will ask you. Do every
That's
kind of failures. Go ahead and do. So that's the one key message I would give to every student.
Thank you so much for that, sir. I'm sure that our listeners are going to walk away with lots of useful knowledge today. It has been truly wonderful hearing about your journey and your experiences. Again, we would like to thank you for giving us your precious time